Welcome to the course. This is Introduction to Azure Networking, and this is Lesson 1, where you'll deploy your first Azure virtual machine. By way of introduction, you'll need an Entra ID tenant and an Azure subscription, access to the Azure portal, and local installations of Visual Studio Code, PowerShell, and the Azure CLI. Links for the above can be found in the course introduction. You'll also need a copy of the deployment script. This is hosted on GitHub, and a link can be found in the resources section. In this lesson, we'll learn how to use resource groups as a container for the deployment, how to create a virtual network with one subnet to provide connectivity for the virtual machine, how to use network security groups and security rules to control network traffic, how to create a public IP address so that we can connect to the virtual machine over the internet, how to create a network interface attached to the subnet to which we'll associate a network security group and the public IP address, and how to create a virtual machine using the network interface and a marketplace operating system image. We'll then connect to the virtual machine over the internet, we'll verify connectivity over the virtual network, and we'll view the effective routes and effective security rules of the network interface. We'll then look at Network Watcher and learn how to use the IP flow verify and next hop utilities. Let's review the topology diagram for this lesson. Here we have a resource group, and inside the resource group we have a virtual machine. The virtual machine has an operating system disk and a network interface. The network interface has a public IP address and a network security group, and the network interface is then attached to a subnet which is part of the virtual network. And now let's see what this looks like in the Azure portal once everything's been deployed. Here we are in the resource group view, and we can see a list of the resources that we've deployed. From the top, we have the virtual machine and its operating system disk. We can then see the public IP address, the network interface, and the network security group. And lastly, we can see the virtual network to which the network interface is connected. Now it's time for our demonstration, so let's get started. Here we are in Visual Studio Code. We have the deployment script open, and our terminal is ready. Before executing the script, let's review it so we can understand what it's doing. From the top, we have our variables. The resource group needs a name and a location. The virtual network needs a name and an address prefix. The subnet also requires a name and an address prefix. The virtual machine requires a name, which we'll then use to standardize the names of its associated resources. These include the network security group, the public IP address, the network interface, and the operating system disk. The virtual machine needs to be sized in terms of CPU and memory. We also need to select the operating system image. And lastly, we need to provide a username and a password. Just a quick side note here, it's not considered good practice to store passwords within scripts, but this has been done here to keep things simple. In a future lesson, we'll see how we can securely store values in an Azure Key Vault and then use the script to retrieve them during the deployment. Now we have our variables defined, we can start to include the resources in the deployment. First, we need a resource group, which just requires a name and location. Next, we need a virtual network. In addition to requiring a name, a resource group, and a location, this also requires an address prefix. Within the virtual network, we need a subnet. For this, we provide the name and resource group of the virtual network, followed by the name and the address prefix of the subnet. We can then create the network security group. This simply requires a name, a resource group, and a location. Before we can create a security rule to control inbound access to the virtual machine, we need to obtain our public IP address. One way to do this is to use the invoke web request commandlet to the IP info API, storing the results in a variable, which we can then access later. We can now create the security rule. This requires the name and resource group of the network security group, along with a number of other parameters. These include the name, direction, and priority, whether the access is to be allowed or denied, the source and destination address prefixes, and the protocol and port. Next, we can create a public IP address, which we'll use to connect to the virtual machine. This also requires a name, a resource group, and location, along with the SKU and the allocation method. Then we can create the network interface. This too requires a name, a resource group and a location, along with the virtual network and subnet name. We also associate the network security group and the public IP address here. Lastly, we create the virtual machine. Again, this requires a name, a resource group and location, but we also need to specify the size, the username and password, the operating system image, the name and performance tier of the disk, and the network interface. We can now execute the script which will deploy the resources. Here we are again in Visual Studio Code, this time with our terminal window maximised. When defining the virtual machine resource, we use the no-wait parameter, so the command will complete before the resource is in a succeeded state. This allows our deployment script to complete promptly, with the virtual machine continuing to provision in the background. Let's execute the script and observe the deployment. If you're following along, in a moment you may wish to pause the video here until the deployment is complete on your side. Now our deployment is complete, let's change over to the Azure portal to review our resources. Here we are in the Azure portal, and this is the resource group view. Let's start with the virtual network. Under settings, we can go into address space. Here we can see which address ranges are allocated to the current network, as well as any peered networks. Next, let's go into connected devices. Here we can see the network interface of the virtual machine, the subnet to which it's attached, along with its current IP address. Next, let's go into subnets. Here we can see the subnet we created, its IP address range, and how many IP addresses are currently available. Lastly, let's go into DNS servers. Here we can see that the network is using the default Azure provided servers for name resolution. Let's go back to the resource group and look at the network interface. Under settings, we can go into IP configurations. Here we can see the virtual network and subnet, along with the private and public IP addresses. Next, let's go into DNS servers. Here we can see that the network interface currently inherits this configuration from the virtual network. Let's go back to the resource group and look at the network security group. Under settings, we can go into the inbound security rules. Here we can see the rule which allows inbound connectivity to the virtual machine over the internet. We can also see the default rules which allow virtual network traffic and traffic source from the Azure load balancer, but which deny everything else. Next, let's go to the outbound security rules. Here we can see the default rules which allow virtual network traffic and traffic destined for the internet, but which deny everything else. Lastly, let's go into the network interfaces. Here we can see that the network security group is associated to the network interface assigned to the virtual machine. Let's go back to the resource group and look at the public IP address. In the overview section, under Essentials, we can see the allocated address, the network interface to which it's associated, and the virtual machine to which it's assigned. Lastly, let's go back to the resource group and look at the virtual machine itself. In the Overview section, under Essentials, we can see that the virtual machine is running, along with details of the operating system, the CPU and memory configuration, the public IP address, and which virtual network it's connected to. We'll copy the public IP address to our clipboard, as we'll need this in a moment to be able to connect to the virtual machine over the internet. Now that we've reviewed our resource deployment, let's switch back to Visual Studio Code and connect to the virtual machine. Here we are again, back in Visual Studio Code. From here, let's use the public IP address of the virtual machine to connect over the internet using the secure shell. Now that we're connected to the virtual machine, let's validate connectivity over the virtual network. First, let's perform a DNS request. We'll look up the Microsoft.com domain using the Google name servers. Here we can see that the request is completed successfully and that Google has responded by providing both the IP version 4 and version 6 addresses for Microsoft.com. Now let's perform a HTTP request and validate our public IP address in the process. We'll use the same IP info API that we used in our deployment script. Here we can see that the request is completed successfully and that the IP info API has responded with the same public IP address that we used to connect to the virtual machine. Now that we've validated connectivity over the virtual network, let's change back to the Azure portal so that we can view the effective routes and effective security rules of the network interface. Here we are back in the Azure portal in the resource group view. Let's go into the network interface and view the effective routes. Let's reorder the routes by address prefix. First, notice that we have a 10.1/16 system route with the next hop type of virtual network. This route allows layer 3 connectivity to all subnets in the virtual network. Next, notice that we have a quad 0 system route with the next hop type of internet. This route allows layer 3 connectivity to the internet. There are also 3 system routes for 10/8, 172.16/12 and 192.168/16 with the next hop type of none. Similarly, there are 2 other system routes, 100.64/10 and 127/8, also with the next hop type of none. The first 3 routes correspond to RFC 1918 and are reserved for private networks. The next route corresponds to RFC 6598, which is reserved for carrier-grade address translation, and the final route corresponds to RFC 5735, which is reserved for loopback. A non-route means that Azure will drop traffic to these destinations. The remaining system routes, also with the next hop type of none, are assigned to Microsoft and other organizations. Next, let's view the effective security rules. Here we can see a similar view of the security rules as to when we reviewed the network security group after the deployment completed. However, this view can be quite useful since it allows us to see a few more details about the rules, including visibility of the address ranges in the virtual network, load balancer, and internet service tags. Next, let's switch over to Network Watcher to demonstrate the IP Flow Verify and Next Hop utilities. Here we are in Network Watcher. Earlier, when we verified connectivity over the virtual network, we performed a DNS request. Let's use IP Flow Verify with the same parameters to see what the virtual network intends to do with this request. We'll select the virtual machine and its network interface. Then we'll select the protocol and the direction and the local port. Next, we'll select the remote IP address and the remote port. Then we choose Verify IP Flow. Here we can see access is allowed and the security rule which permits the traffic is the default Allow Internet Outbound. Now, let's use the Next Hop utility to verify some of the system routes we saw earlier when reviewing the effective routes of the network interface. The Azure portal's completed most of the fields for us, so first let's check another address on the virtual network. Here we can see that the next hop is the system route virtual network. Next, let's check an address on the internet. Here we can see that the next hop is the system route internet. And finally, let's check an address in RFC 1918. Here we can see that the next hop is the system route none, which means Azure will drop this traffic. That concludes this lesson. I hope to see you in the next one, where you'll learn how to add a second virtual machine to the existing subnet in the virtual network you've already created. See you next time.